In your lesson today, we're going to have an introduction to evaluating integer expressions. And before we start to evaluate expressions, we're going to talk about a couple of terms that you're going to hear a lot in this topic. The first is called a constant. A constant is a fixed value. A fixed value. Okay? Examples of constants are just plain numbers like 2 or -7 or 1/2. Okay, these are called constants because their values never change. 2 is always 2, -7 is always -7, 1/2 is always 1/2. They're constant. A variable is a placeholder. We call a variable a placeholder for an unknown value. A placeholder for an unknown value. That's what a variable is. All right, and we use lots of different variables. We can use a, we can use x, we can use n. Okay, these are just examples of different variables that we can use in algebra. Now, there are different terms that we're going to look at. We talked here before about constant terms. Constant terms are just these fixed values. We can also have a variable term. A variable term is a term that has a variable in it. For example, -3a squared. This here is called a variable term. Okay, and there are different parts of a variable term. The first is called the numerical coefficient. The numerical coefficient in this case is this -3. Okay, the numerical coefficient is the multiplier of the term. Okay, -3 is multiplying a to the second power. The base in this example is the variable a. Okay, the base is the variable a. And remember the exponent of 2. The exponent is the number that states how many times the base is used as a factor. Okay, and so if we were to expand a to the second power, that would mean to do a times a. So the coefficient is the -3, it's the multiplier. The base is our variable in this case, and the exponent 2 tells us how many times to use the base as a factor. In this variable term, we have 2a. 2a means 2 times a. If you have a number and a variable right next to each other, that's multiplication, 2 times a. If we have a fraction written like this, 2 over a, this means 2 divided by a. 2 divided by a. Okay, so you're going to see a lot of things that look like these in this topic. Remember that if we have a number and a variable together like this, it's multiplication. And if we have it written like a fraction, it's going to be division. Now, we're going to focus on evaluating expressions. Anytime I want you to evaluate an expression, I need to tell you first what the values of the variables are. I couldn't be able to evaluate this expression if I didn't know the values of a and b. If I give you the values of a and b, the first thing you're going to do is substitute those values for the variables first. Okay, so this expression, -2ab means -2 times a times b. So I'm just going to replace a and b with their values. -2 times a is 5, and b is -6, plus 3 times b. 3 times b is -6, plus 4. After you do the substitution, then you just follow your order of operations until you can evaluate what the expression is going to be. So in this first case, I'm going to multiply -2 times 5. I see multiplication, addition, more multiplication, more addition. I'm going to do my multiplication first. -2 times 5 is going to equal -10. And I'm just going to bring down everything else. Times -6 plus 3 times -6 plus 4. Okay? I still have multiplication that I need to take care of. I've got multiplication here and here, so I'll take care of those together now. -10 times -6, a negative times a negative is a positive, so this is going to be positive 60, all right? Plus, 3 times -6, a positive times a negative is a negative, this is going to be -18, and then I'm going to bring down the plus 4. Okay, and now I just have addition left, so I'm going to go in order from left to right. 60 plus -18, well, they're different signs. That's going to leave me with a positive 42, and now I'm going to add 4 to that. And I'm going to get a final answer of 46. So the value of this expression, after I simplify my expression by substituting these values in, I get a value of 46. In example 2, again, I've got this expression. I told you the values of x and y. The first thing I'm going to do is substitute in the values of the variables. Negative 3 times x is negative 4 times y is 3, and that has to be raised to the second power. Order of operations, I'm going to evaluate the exponent first. 3 to the second power is 9, so I have negative 3 times negative 4 times 9. And now this is all just multiplication, so I'm going to go in order from left to right. Negative 3 times negative 4 is positive 12. And now if I do 12 times 9, I'm going to get 108. 108 is my final answer for this expression. Same thing in number 3. I gave you the values of a and b. Substitute in these values first. In the numerator, I have 3 times a times b. So this is going to become 3 times negative 3 times 5. And in the denominator, I just have 3 times b, so 3 times 5. Okay, well, if I evaluate in the numerator first, 3 times negative 3, this is negative 9 times 5. In the denominator, 3 times 5 is 15. Okay, back in the numerator, I have negative 9 times 5, which is negative 45. And my denominator is still 15. Remember that this means to divide. Negative 45 divided by 15, my answer here is going to be negative 3. Okay, so the answer for this expression is going to be negative 3. On this page, we have a lot of practice examples where we can evaluate our expressions. I'm not going to do all of these in this video, but I'm going to highlight some of the ones that I think are important to talk about. Starting with number 4. I have negative and then in parentheses a. Okay, and we need to understand that this negative symbol outside is really the number negative 1. So this is really saying negative 1 times whatever the value of a is. And so if I make my substitution of a, okay, I'm going to have negative 1 times a is negative 8. And so I'm really just going to multiply negative 1 by negative 8, and that's going to give me an answer of positive 8. So always remember, this negative symbol sitting out front here is really understood to be the number negative 1, and it's multiplying whatever the value of a is. Right underneath that, in example number 7, I have a, and it's being raised to the second power. Okay, and so all I'm going to do is take the value of a, in this case it's negative 8, put it inside of the parentheses there, and I'm going to raise it to the second power. Remember, this means to do negative 8 times negative 8. A negative times a negative is a positive, so my answer here is going to be 64. Right next to that, okay, these look similar, but now we've got this negative symbol outside. So remember, this is the number negative 1. Negative 1 times a's value is negative 8, and I'm raising that to the second power. Okay, I have to evaluate my exponent before I do the multiplication. Negative 8 to the second power, we just said, was 64. So this is negative 1 times 64, which is going to give me a final answer of negative 64. Okay, looking at example 10, in example number 10, we have negative 2a inside of the parentheses. Okay, so what I'm going to do first is make my substitution of a. In the parentheses, I have negative 2 times negative 3. And then I'm going to take that value and I'm going to raise it to the second power. Inside of the parentheses, I've got to do my multiplication first. Negative 2 times negative 3 has a value of 6. So inside of the parentheses, I have 6, and I'm going to raise that to the second power, which means to do 6 times 6. 6 times 6 has a value of 36. Okay. Next example I want to do with you is example number 14. First thing I'm going to do, as always, I'm going to substitute in the value of my variables. 4 times, in parentheses, x is 2 plus 3 times y, which in this case is negative 7. Inside of the parentheses, I have to do any operations, but I see addition and multiplication, so I'm going to multiply first. 4 times, in parentheses, 2 plus 3 times negative 7 is negative 21. I still have to work with this addition first. 2 plus negative 21 is negative 19. So this is 4 times negative 19. And now I'm just going to do this multiplication. 4 times negative 19 is going to be negative 76. Okay? Looking at example 15, again, the first thing I'm going to do is substitute in the values of my variables. 4 times x, the value of x is 2, and that's being raised to the second power, plus 3 times y, so it's 3 times negative 7. Order of operations says I'm going to evaluate my exponent first. 2 to the second power is 4. 4 times 4 plus 3 times negative 7. 4 times 4 has a value of 16. I'm going to do my multiplications first. Okay, addition and multiplication over here. I'm going to do this multiplication, so I'm going to bring down 16 plus 3 times negative 7 is negative 21. And now I'm just going to add 16 and negative 21. They're different signs. This is going to give me an answer of negative 5. In questions 18 and 19, I have examples of work that people have done substituting in the value of their variable and then evaluating, and in each case, they've made an error. Okay, and so what we want to do is go through and see if we can identify what the error was. In question 18, it says, describe and correct the error if x is equal to 7. So we started with the expression 5 plus 4x. This person took the value of x and replaced it with 7, so it's 5 plus 4 times 7. And then we have 9 times 7, which equals 63. And it all looks good mathematically, but we need to remember the order of operations. And the error happens right here. Okay? We see we've got addition and we've got multiplication. In order of operations, we're supposed to multiply first, but this person did the addition first. Okay, so we're going to write that down. This person added before multiplying. This person added before multiplying. Okay, so we've described the error. Now we're actually going to correct it. And so we're going to write down all the work that should be written down. 5 plus 4x. The value of x we said was 7. So we have 5 plus 4 times 7. That was all good work over here. But now we need to remember to multiply first. 4 times 7 is 28. 5 plus 28 is going to give us an answer of 33. So the correct value of this expression would be 33. In example 19, again, the person has made an error. It says describe and correct the error if x equals 3. So we have negative 4x to the second power. They replaced x with 3. Okay, and then we've got 4 times negative 3 is negative 12. Negative 12 to the second power means to do negative 12 times negative 12, which is 144. But again, an error has been made right here. We know with order of operations that we're supposed to evaluate the exponent before we do the multiplication. Okay, and so we're going to just describe that error. This person multiplied before evaluating the exponent. This person multiplied before evaluating the exponent. Okay, so now that we've identified the error, let's go ahead and fix the error. The expression says negative 4x to the second power. Replace x with the value of 3. They told us that x equals 3. Now we're going to evaluate the exponent first. 3 to the second power means to do 3 times 3, which is 9. So we have negative 4 times 9. They're different signs, and so this is going to give us a product of negative 36. So the correct answer for this expression would be negative 36.